Everybody was able to graph it, right?
No.
Kind of.
Yeah.
Put it in slope-intercept form.
What?
What?
They just isolated y.
I just substitute.
Oh, once you isolate y, you know the slope and what the...
Isolating y is putting it into slope-intercept form.
I know.
That's exactly what I said.
I know.
Okay.
I'm rephrasing it.
All right.
Can you just like put in x and y values?
Yeah, you could, but why would you do that?
Why not?
And then you get the...
Like if it's like just a,
Yeah.
depends how easy it is to change the slope intercept. Like sometimes it's easier just to like plug in two numbers.
Whatever you need to do to graph it, buddy.
Whatever.
You do whatever floats your boat. Whatever paddles your canoe. Whatever
It's nothing edges.
holds up your broken leg.
Whatever fills your boat.
Doesn't matter. All right? Is everybody good? Now listen to me. Listen to me. Do not, and I'm speaking to specific people in the class, do not say this next thing out loud. The next instruction says pick a number. Pick a number anywhere between -10 and +10, but it cannot be -1, 0, or 1. Okay? Once you have that number, do what I asked you to do. Take the number that you have done. I am going to use the number -5.
That's the same number I chose.
Unbelievable. Great minds think alike. Then multiply both sides of the second equation by that number and solve for y, and tell me what happens. The second equation, in case you forget, is 5x minus 3y equals 27.
Okay, so the original, not the... Okay.
Then answer the question that says, what do you notice? Do not answer it out loud. Answer it on your piece of paper. What did you notice when you multiplied both sides of the equation by that number and then solved for y again? Just like it says to do on the piece of paper. Has everybody done it yet? If you can't tell me what you notice, then you haven't finished the math.
Solve for y by doing the substitution?
No.
Oh, no, just... Oh,
Just get y by itself. That's what solve for y means. Remind me next year to just choose the number and make it 2.
Mr. Myers, is it still okay if I write my math exam tomorrow?
Yes, it is.
So is this going to be on the math exam?
Yes, it will. It will not be on its own test. It will be on the... There will be a few questions of it on the exam.
A substitution?
Yes. All right. What did you notice? That you get the exact same line. If you didn't get the exact same line, your algebra is poopy and you'd best practice.
What's that? Well, actually, if I simplify, I do. I just didn't simplify.
Well, you simplify always. At any rate, you notice you get the same line. So what does that tell us? If something happens once in math, how often does it happen?
Always.
Always. So multiplying both sides of linear equation results in the same line on a graph, which means it is technically the same equation.
That's why when we have a fraction on one, we can multiply both sides.
Strong.
Boom.
It was supposed to push me back.
Okay.
Strong. There we go. First try, Lego Batman.
Yeah.
Okay. Now, next thing. Add these equations and graph the result. So let's add the equations. What is 4x plus 5x? 9x. What is 3 plus negative 3? 0. What is 0 plus 27? 27. To graph that, I must have to get x by itself, yes? So what does x equal? 3. So what happened when I added them?
The y.
Right. The y variable disappeared. Right? Now, if I graph that, where is x equals 3? 1, 2, 3. And that's the line, yes? What just happened?
It's magic happened.
It hit the
point, the solution.
intersection point at the x value. So,
I think Mr. Myers I missed that.
what did you miss?
You got the y variable disappears.
Then we graphed it.
Oh.
X equals 3. Vroom. And notice it went through the solution. So what does that tell us? If the y disappears, we get the x value of the solution. Now, once that is proven, what would happen if the x value disappeared? You're like Sherlock Holmes over there. If the x disappears, we'd get the y value. Okay? Okay. Now, this question says subtract. So, let's subtract. We're going to subtract upwards, okay? Because I screwed up the typing and there's no room here. What is 5 minus 4? X. What is negative 3 minus 3? We're subtracting. Negative 6y. And what is 27 minus 0? 27. Graph that. What do you have to do? Negative 6y equals negative x plus 27. Y equals 1/6 x minus 27 over 6, which is 9/2. Yes? Everyone agree? Now, if I graph that, let's go back to the top. 1/6 x minus 9/2. Now, minus 9/2 is my intercept, yes? Which is minus 4.5. 1, 2, 3, 4.5. Everyone agree? And I got to go up 1 and right 6, yes? So up 1 to 3.5, But I got to wait till my computer thaws so this all happens at once, or it'll screw everybody up. Up 1 and out 6. 1, 2, 3, 4, 5, 6. Right there, yes? What happened that time? It goes through the solution again. So, what does that tell us?
That if we subtract and then we add.
Adding or subtracting two linear equations results in what?
Solution.
Results in
The line intersects.
third equations which still share solutions. So what does that tell us? If I have a system, can I multiply them and still keep the same solution? 1 sec, Lauren. Can I multiply them and still keep the same solution? Okay. Can I add them and keep the same solution? Can I subtract them and keep the same solution? If I can multiply them, can I divide them and keep the same solution? Yes, because dividing is just multiplying by a fraction. So, am I allowed to change the way the equations look so I can do algebra and still keep the same solution? Yes. Lauren, go.
Why did you put the dot where you did on the y-axis for that last one?
Because the intercept was negative 9 over 2, which is 9 divided by 2, which is negative 4 and a half. So I went down 4 and a half.
Okay, sorry.
Everybody cool? All right, so now there are how many answers could you write in there? Read the instruction and tell me how many different answers you could put in there. Infinite. Why?
Because you can have a lot of different things with the same satisfaction.
I can multiply these by anything. Or I can add them, or I can subtract them. Does everybody understand?
Yes.
Lauren.
But if the slope is 1 over 6, then you're going up 1, which is still halfway through, so then it doesn't actually reach the 3. But the
Okay.
one point that it makes, it goes through the point.
Are you good with that? At negative 4 and a half. What is 1 up from negative 4 and a half? Negative 3 and a half. Now I must run 6. 1, 2, 3, 4, 5, 6, correct? Now I must connect those lines. And where does the gray line go when I connect them? Right through the solution. Okay. So, we can have an infinite number of answers there. Now, all of that now tells you the following. To solve by elimination, add or subtract to get rid of one variable, solve for the remaining variable, and then do substitution. So looking at this, what could I do to make either the x or the y disappear? If I add them, what will happen, Leighton? When I add them, 3 plus 4 is what? 7x. Negative 5 plus 5 is what? 0. Negative 9 plus 23 is what? 14. What does x equal? 2. X is 2. What does that mean I can do everywhere I see an x? I can put a 2. So, 4 times 2 plus 5y equals 23. 8 plus 5y equals 23. 5y equals 15. Y equals 3. What now is my ordered pair? 2, 3. Am I doing this right? Thank you, Harmon. you'll check. Why are you able to check? Because you have an x and a y. What's 3 times 2? 6. What's... Oh, did I screw that up? Yeah, I forgot to do... No, I was right. What is 5 times 3?
15.
What is 6 minus 15? Negative 9. Done. Everybody good? So now let's look at this question. And why was Leighton immediately able to say you're adding?
Because it's already a negative and a positive.
Because you have a negative and a positive that are the same coefficient.
Yeah.
So this is what allowed Leighton to say add. Everybody cool?
Wait, is it Leighton? Okay.
So, what's your reminder here? Same coefficient. Different sign. Add. Everybody got it? Look at the next question. What's wrong with question 3?
They're not the same.
I got none of them that are the same.
No.
But what am I allowed to do to change how something looks? I can make it multiply. What would happen if I were to multiply this equation by 2? What would I get?
We had to multiply all of them by 2. So 2x minus 4y.
2x minus 4y equals 14. What do you see?
Oh my
It
god.
cancels out.
It cancels out. So,
Everybody can.
let's make this happen. Since they're the same coefficient with a different sign, what do?
Add.
Add. What's 3 plus 2?
5.
Equals?
15.
What does x equal?
30.
3. Where does that 3 now go?
You have to substitute for the x.
Anywhere I see an x. Is that an x?
Yes.
Can I put 3 there?
Yeah.
Sure I can. 3 minus 2y equals 7. Negative 2y equals 4. Y equals negative 2. What's my ordered pair? 3, negative 2. Am I doing this right? Check! Class, did we do it right?
I didn't know. Can you check?
I'm asking you to check. I have reversed the role. I am now being you people.
Yeah, you can. You can do whatever you want.
That's not how I sound. It's not even close to how I sound.
Mr. Myers, did you like the David's tea?
I did. I've been drinking it constantly.
Really?
Yes. Constant. No, it doesn't work. But yeah.
Try.
Yeah.
Now, what's wrong with the third one?
You can't multiply it by 2 to cancel out.
I can't multiply it by 2 because then I'll have 6 and 2 or 4 and 3. Oh no! Fortunately, we have skills in math class. What would you do to add those?
You give them a common denominator.
Of what?
6.
6. So you would have had to change both denominators, right? So in this question, I need a common coefficient. So I must need to change both coefficients. What's the easiest way to find that common denominator? Multiply them by each other. So what's the easiest way to find the common coefficient?
There you go.
Multiply them by each other. Could I multiply this guy by 11 and this guy by 2? If I wanted to. Could I multiply this guy by 2 and this guy by 3? If I wanted to. Doesn't matter which one I do. Nope. Which one should we do? The easier one, which is 2 and 3. So this guy's getting multiplied by what? 2, which means he becomes what? And this guy's getting multiplied by what? 3. So what does he become? 33x plus 6y equals negative 3. Are they the same number with different signs? So what do? What do we do? Add or subtract? Add. 4 plus 33, 37x. 40 minus 3, 37. What does x equal? 1.
Oh my goodness.
Where does that x go? Anywhere I see an x. 2 times 1 minus 3y equals 20. 2 minus 3y equals 20. Minus 3y equals 18. Y equals negative 6. What's the ordered pair? 1 minus 6. Class, they do it right,
Well, I don't know. You can check them, can't you?
I don't sound like that.
I know you don't, but I just want to say it because it's less
It's hurtful.
It's a deep masculine voice. You can't say. Yeah, sure, yeah, but I don't know you.
Is everybody good? Now, stop for a moment. What would you do with this one? You could multiply 1 by negative 1, and then you could get rid of the x. Or you could subtract. Right? Because as long as you can eliminate, you would eliminate. Right? Right? So you could do subtraction, which would give you what? Negative 5y equaled negative 10. Everybody agree? Okay, wait. What would you do with this one?
So, quick question. What would happen if I got both of them crossed out?
Then there's no solution. I think I should start putting a stopwatch on how long I have to wait for this thing to be thawed every day.
Or like combined minutes of it.
Which then I would add up at the end of the year. And then I would divide that by the amount of hours I spend in school and send it to Microsoft and tell them they owe me that much money.
Okay.
3x minus
And then
6y
be like, I want to meet Bill Gates, and then he tell Bill
and
Gates.
3x minus 2 equals,
I think if Mr. Myers became a multi-billionaire, he would not give up his teaching job.
Now what would you do? If I became a multi-bazillionaire, I would open a school and I would treat you people the way you should be treated. No, I would treat you the way you should be treated, which is, you're late, goodbye, get out of my school.
Oh, yeah.
You didn't show up for that big presentation that you were supposed to do for the bosses? Goodbye, you're out of my school.
Thank you.
You can't do anything on this sheet of paper? You fail, goodbye, get out of my school. That is what I would do if I was a bazillionaire. I would open my own school and would actually prepare you for life. And by the way, even with those rules, I would still have a lineup out the door every day of parents wishing to get their kids into it. Plus, you would all wear uniforms.
Yes.
Plus, the teachers would all wear nice clothes.
Yes.
Why? Because I am tired of seeing a kid who decides that he or she would like to wear a shirt that doesn't have a little polo player on it. So the kid doesn't get bugged for it. You would not be allowed to wear earrings. You would not be allowed to bring any technology except a calculator, which would be provided by the school and part of your school fees. So everyone had the same calculator. And all that stuff. You know why? Because then anything you choose to bully somebody about, that's your hang up. And it's easy to find out and it's easy to stop. What about our individuality? Beauty is skin deep. Individuality is deeper than your clothes. Be your own person. Doesn't matter what you're wearing. What?
One of the reasons why there is like uniforms. Is that one of the reasons why?
Yeah.
Well, that's one of the philosophical reasons behind it. I personally believe it's so the people that run the schools that make you wear uniforms can say, our kids are better than those kids.
Okay.
That's the real
As
reason.
someone who spent the last 2 years wearing a suit and tie to school every day,
Yes.
I promise you the novelty gets very old very quickly.
Of course it does.
But I miss wearing
And-
uniforms. Uniforms are nice because you
This
just
is
wear it.
so uncomfortable.
I'm well aware of that, but I'm also well aware that I have a teenage daughter, or a preteen daughter, that stands in front of her mirror every morning trying to choose clothes.
You wear like a skirt
Like,
or you
I
wear pants
understand
or
that
shorts.
levels of like,
No, that's not a uniform. That's not a uniform.
Well, it was a uniform.
No,
was a
it
dress
isn't.
code.
That's a dress code.
Very-
That's different.
Very.
Yes, no. That's a dress code. That's not a uniform. A uniform is you wear this. One form.
It wasn't much. It was dumb because the people would still get bullied because of what they were wearing.
like I understand it.
It was different. It wasn't in the uniform. But then, would you like switch it up when it during the summer months to like like
I don't know.
or like something like?
I don't know. Because it's moot. It will never happen. I will never be a multi-billionaire.
True.
Now, back to this. What would you do here? You would subtract again. So you would get what? 0. What would you get here? No. Negative 4y equals what? Negative 7. And then you would continue to solve. Oh my goodness, Mr. Myers, you're so mean. That's going to give me a fraction. Yeah, it might. Just like in the real world, when you're doing real life work, sometimes you're not going to get an exact number. And you're still going to need to do the work. You don't get to say to your boss, there's a decimal in the answer. I couldn't finish it. I'm sorry, man. Oh, I've been working for 1 hour. I think it's break time. Okay. The point I'm trying to make is if you're going to subtract, you'd better remember that subtracting a negative is adding. Or you do what Sarah said and you multiply by -1 to get it negative so you can just add. Totally up to you. Why are you showing us more than one way, Mr. Myers? Because some people will prefer to just do subtraction and not want to run the risk of remembering how many signs they need to change when they multiply by a negative. Okay? Okay. And finally, I lie. What would you do with this?
It's bad time. That's what it is. What? Oh, no.
What would you do with that one?
You would times it by 4.
Why by 4?
-4.
Why by -4?
Because then the x you do the drop out.
Half of -4 is 2. -2. So you could make it drop out.
Then it'd be all good.
Then you would just add. Pardon me? Elimination, you mean. This is your favorite way to solve a system. Mine too. It is. But every year, in the old times, when I first started teaching, the very first year I ever taught this, I taught substitution first. And the kids were all like, we don't get it. And then I taught them in elimination. They were like, we get it. Why didn't you teach us elimination first? It's way easier. So next year, I reversed it. Guess what happened? We don't get it. Then I did substitution. This is way easier. Why didn't you teach us this first? So the next year I switched it. Guess what happened? We can't do substitution. It's so hard. Why didn't you teach us elimination first? So now I just left it and don't care. Learn them both. because it doesn't matter what order I put it in. Because kids are just generally contrary. No matter what I do, you're going to say, why are you doing this way? And it's all right. I was the same way when I was your age. Your grandchildren will treat you that way. Well, they won't, because every grandparent spoils their grandchildren. Your kids will treat you that way. And you will say, why are you being that way? I wasn't like that when you were a kid. And then I will bust into your house like the Kool-Aid man and say, as a matter of fact, you were. And then I'll leave. Well, I won't, but your parents will. While they are spoiling your children, their grandchildren. They will behind your back be telling your children what a pain in the ass you were when you were their age.
All my grandparents do that as well.
Yes, all the time. And your dad forgets that your dad was once your age, just like every parent does. I, fortunately for my kids, see what kids are like every day, all day. So it's not a problem. I never forget. Doesn't mean I like it.
Yeah, PTSD is gonna start going out.
All right. Tomorrow we'll finish up. You guys got some work you could be